Welcome to the deep dive. So, you're looking to get up to speed quickly on new fields, right?
Yeah, get the essentials fast.
Okay, so today we're diving into something interesting. Proprietary AI courses aimed at students, grades 3 through 12.
hmm AI for kids, essentially. It's a big topic now.
Exactly. We've got curriculum outlines here from a company called Mastix Ed. Their mission statement is revolutionizing AI learning for everyone.
Quite ambitious.
And the materials seem to be authored by Saikat Basu, described as an innovator, educator, and global changemaker.
Okay.
So our mission for this deep dive is pretty straightforward. Figure out the structure, the focus of these AI courses for, young learners. What are they actually teaching?
All right, what concepts are they introducing and how early? It's definitely worth exploring how AI is being presented to the next generation.
Totally. And just looking at the course titles gives you a feel for the progression.
Oh, yeah. Like what?
Well, for the younger kids, there's AI Adventures, exploring the world of smart machines. Sounds fun, right?
Yeah, approachable. Like an entry point.
Then it moves up.
Yeah.
Titles like AI Navigators, Exploring Intelligence Systems, AI Innovators, Building the Future, then AI Architects, Designing Intelligent Systems.
Okay, I see. It's like steps on a ladder. Exploring, navigating, innovating, architecting.
Exactly. And it keeps going. AI Pioneers, Engineering Intelligent Solutions, AI Mavericks, Architecting Intelligent Futures, even AI Alchemists, transforming data into intelligence.
Alchemists, huh? That's a creative one. Suggest something more complex with data.
Yeah, and finally, AI engineers, designing intelligent agents, so you can sort of see the whole path laid out.
You really can.
Huh.
It suggests a clear developmental journey from basic awareness to, well, pretty sophisticated design and engineering concepts, intelligent systems, intelligent agents, getting quite specific.
Now, two courses really jumped out at me, focusing more on the math side.
Okay.
First, Calculus-Driven AI Foundations and Applications. It apparently builds on single variable calculus.
So bringing in the math foundation early, or at least for the older students, presumably.
Seems like it. The idea is to connect that calculus theory directly to practical AI algorithm projects. And interestingly, they say it doesn't require, super powerful computers.
That's key, making it accessible. It's not just abstract math, then.
Doesn't sound like it. More about using calculus as the language to understand how these algorithms actually work, translating formulas into code.
Right, building that intuition. That makes sense for really understanding AI, not just using libraries blindly.
Then there's the other one, Mathematical Foundations of Advanced AI. This sounds pretty intense. It's a 36-hour course listed for 12th graders.
Okay, end of high school. What's needed for that?
Prerequisites are, significant. Calculus, algebra, and probability.
So a solid math background is expected. Makes sense for advanced AI.
Yeah. And this one dives deep into the, quote, mathematical machinery behind complex algorithms.
The machinery, I like that. So theory and practice again.
It's like it. They mention rigorous mathematical derivations combined with Python implementation.
Using the standard tools, I bet.
Yep. Lists NumPy, SciPy, SymPy, Pandas, Matplotlib, Seaborn, Scikit-learn, and TensorFlow or Keras.
Okay, the usual suspects, the industry standards, really,
Okay.
and likely a project.
It mentions a significant final project.
I know.
So, yeah, applying all that complex math.
That level of mathematical depth combined with coding in 12th grade,
Yeah.
that's pretty advanced. Could be really impactful.
And both of these math-heavy courses are tied back to Saikat Basu, the educator we mentioned.
Right, the innovator-educator guy.
Yeah, his bio emphasizes transforming industries, philanthropy, and bridging that knowledge gap in AI education via Mastix Ed.
So the person behind it seems focused on practical application and making this stuff accessible. Despite the complexity, it fits.
Okay, so if we try to, boil it down, what are we seeing here?
Well, it seems like a structured, progressive approach, starting young, building up concepts.
And a really strong emphasis, maybe surprisingly strong for some, on the mathematical foundations, not just coding.
Exactly. It's not just how to code a thing,
Yeah.
but why the thing works because of the math.
Yeah.
And linking it all through practical projects.
Understanding the core principles.
That seems to be the goal, building real understanding from the ground up.
Right. So this brings us to maybe a final thought for you, the listener, to chew on. How might this kind of early and pretty deep exposure to AI concepts, and crucially the math underneath, how might that shape the way the next generation thinks about and develops AI?
Yeah, that's a big question. What happens when kids grow up fluent, not just in using AI, but in understanding its mathematical roots.
Yeah.
What opportunities, what challenges.
Well, what kind of innovation becomes possible then? Something to think about. Thanks for taking this deep dive with us.